Hi there, in this tutorial we are going to make an on-screen a virtual keyboard, and we're going to use it to send, it's going to be sending OSC messages, Open Sound Control messages. In this case we'll be sending it to an instrument I've made earlier in SuperCollider. If you want to look at previous videos for that, a mouse theremin. But really could be used for anything that's you can send OSC messages to. Okay, so speaking of OSC, then let's get started by setting up our OSC machinery. What we'll do is we'll import the libraries first. So if we go to Sketch, Import Library, and I already have the library installed, so I'm just going to add that. It will add the text for my library, OSC P5 and Net P5. What I like to do now is set up the machinery for sending OSC messages. So I'll go OSC P5 and I'll create a variable OSC for that. And then I'll declare another variable, net address. And this is going to call SC for SuperCollider, and that's where I'm sending my messages to. And then I will create the setup. And I'll create the draw. So what I'm going to do right now, well, I'll set up my OSC, but let's declare size. And I think I made it 1000 by 200. Okay. And then I'm going to set up my OSC variables. I'm going to initialize them. So my OSC machinery, OSC equals new OSC P5. This is its context and its port number 12321, which is just one I made up. Just has to be within a certain range, I think. They'll be acceptable. And certain ports, I think, are taken up by the internet and such. And then set up my net address as well. So SC SuperCollider will be a new net address, and it will be IP address of 127.0.0.1, just sending to myself. And the default port for the SE Lang or the client side is 57120. Okay. Now, what I'd like to do as far as the graphics go is I'd like to set up one key and show you how to do one, and then show you the process, and then revise the code completely and show you the process of really making multiple keys with changing just a few variables. All right. So let's start in on draw. And let's just do the one key, and then we'll scrap that code and revise it to show you how to make it a multiple. And so maybe this is a good point to talk about the fact that we'll be using a few concepts, namely learning to declare variables or store variables in arrays, so sets of variables that are recallable by an index number, and then using the process of using a for loop that will then scroll through all the arrays and grab the corresponding variables. But more on that later. So for now, let's have a background. I'll make it black. And then let's just draw our one key. Okay. So, oh, sorry. So, actually, before we do this, let's go ahead and let me see actually what I end up doing. Do I do it in draw? Right, okay. Right, okay. So let's first go ahead and set our mouse up really to give pitch and amplitude information. So if you wanted to use your mouse on this keyboard, you would give pitch and amplitude information from your mouse. Okay, so let's go ahead and just set up those variables. All right, so we'll do that first before we delve into the keyboard, because that will be the information we need. So we're going to create a variable. We'll make it a float, and we'll call it pitch. Okay, and we'll just make it equal to, and these will be MIDI pitch numbers. All right, even though we'll send them as floats. So you can have quarter pitches and such, half pitches etc., etc. And let's just give it a default of 60. Okay, oops. And then we'll have another float amp, and we'll give it a default of 1. All right. So what we're going to do is we're just going to map, because we're going to normalize everything. And so we're going to map we're going to map these variables to a certain range, all right? So that we can contain a range within in a format that's acceptable to SuperCollider, that'll actually play the pitches we want. Okay, so we're going to create another float. We're going to call it pitch low, and this one we'll set to, let's do a 2-octave range. We'll set to 48. Okay, and then we'll have a float pitch high, and then let's say that's 72. Okay, so that's the octave above and below middle C. That's our range. All right, and then right. Okay, so if we want to map those to into values that are useful to SuperCollider, we're going to take a pitch. Let's do pitch first. Okay, and then we're going to equals. We're going to map the mouse x. We'll make the mouse x our pitch, the x-axis our pitch. So we're going to equals to, we'll use the map function. Okay, and map takes the input, and then it takes the input's range of low and high, and then it takes the output the desired output of low and high. Okay, and then we don't need that comma. That's how that works. So the first, I'll just type these in here. So it's input, and then it's input range low, input range high. Okay, and this is output range low and output high. And that's how map works. And of course you can look it up in the reference. So our input's going to be mouse x. Right? So wherever our mouse x. And our input range is, because mouse x only gives you new data when it's touching the actual canvas, the sketch. If your sketches lose focus or you draw off the range of the sketch, it stops giving you output. So we have then our x-axis is really 0 to the width of the canvas, right? Okay, and then what our desired output is the pitch range. So we want pitch low and pitch high, right? Because we want it between this 2-octave range, which is variable, so we can always change that. If we want to make a very, a multi-octave, say 10-octave keyboard, we can do that as well. We'll just change these two to our desired starting and ending pitches. Okay. Now, right, then let's do amplitude as well. For amp, we can use, because we're expecting in SuperCollider a number between 0 and 1. So for amp, we can use the function called norm or normalize, which just takes any range and maps it to a 0 to 1 range, which is typically the most useful range to have numbers, because you can do multiplications and divisions and such. So we're going to use the function norm, and it takes the same arguments as map. However, it doesn't have an output range because we always presume the output range to be 0 to 1. So just 3 arguments, which is the input. So we're making our mouse y the amplitude, so mouse y. The input range will be then, so it's backwards in the axis, right, in processing. So the top y, the very top of the sketch, is 0, y 0. And the very bottom of the sketch, y is height, or the maximum y. So we want to do a reverse, because intuitively we want to go up towards the top of the screen to make things louder. So we're going to go from height to 0. Okay. So height to 0 will map from 1, 0 to 1. Okay. So that's our amp mapped and our pitch mapped. So now we have, as we move our mouse, we have 2 variables that will be constantly changing at the draw rate that will reflect the amplitude and pitch we want to give. Okay, so now let's start the drawing. Let's get back to our keyboard. So we want a keyboard, so we want some visual representations, a visual guidance, diagram in this form of a keyboard to guide us to know, so we know what pitch we're playing, and obviously up and down can be amplitude. All right, so what we'll do is we'll create, so it's a black background, which I think at this point doesn't matter too much. We'll create white keys, but we'll need some kind of outline. So we'll have a stroke. Let's do a stroke weight. We can adjust this. Let's make it 3 for now. And then we'll have a stroke. And let's make it black. Okay. And then no fill. Oh no, I guess our fill will be white. Okay, we'll do that. Let's draw a rectangle. So let's draw our key to the left, and we'll say, I guess we have to do some kind of sort of general calculation. If we think about it, I guess we'll have to divide so if we have 2 octaves, that's 24 keys, and divide the width by 24, which in this case is 1,000. Well, since we're just setting it up one, we'll just, for simplicity's sake, just do 25, and whatever that is, 4 times 10, 40. Okay, so the width will be 40. So we'll make a rect. We'll start it at 0, 0, right? Because we want the first key to be starting in the upper left-hand corner of our sketch. So 0 x, 0 y, and then we'll just have it be 40 wide, and then we'll have the length be the whole width of the sketch for now. Height, I'm sorry, of the sketch. Okay, so if we draw that, we'll have a nice looking piano key there. All right, so if we wanted to do that over and over again, we could. Right, we could do that. We just have to make a whole bunch of rectangles, and we'd have to just calculate it. But the only thing that I'll draw a couple more, but so that we can notice that the only thing that really moves is its x location, right? So if we did that, instead of start that at 40, we're still at y0, and we're still 40 width, and then height, and then we can draw a third if you want. Okay, so then that would be 80, right? So we're really incrementing just the x. We're scooting it over. So now we have 3 keys there, right? And that kind of works nicely. Okay, so right. So then how do we make this multiple now in an easy way? Okay. Get into the process of having a for loop and arrays of variables. Well, in this case, actually, we don't even need arrays of variables. So I scratch that. We'll take that on in in a more advanced tutorial later on. But really, we're just using for loops to create multiple keys. So a couple bits of information we need to have. We're going to first get a range. We're going to have a float, and it's going to be our range from pitch low to pitch high in MIDI pitches. So we're going to have pitch low, and we'll set that to 1 octave below middle C, say 48. And then we're going to go another float, pitch high, and that will equal to 1 octave above, or 72. And then let's go ahead and there's 3 things we have to calculate. We're going to have to calculate the number of keys. Let's make that a float, because it could be half a key, for example, if we do weird ranges. And we'll just leave that just declared but not initialized. And then we'll have a couple other floats, and they will be, we'll have to calculate the key, the width of the key, and the height of the key. Okay, so let's go ahead and do that in setup then. Scroll down a little bit. And let's figure out the number of keys first. And that's going to be equal simply to the pitch high minus the pitch low. Right? Okay. And that'll give us a total number of keys that we need. And then we calculate the key width by taking the total width and dividing it by the number of keys. So that'll give us the width of one single key, right? And then if we're going to do the key height, you can be whatever you want, but I'll make it the total height of our canvas. So I'll just say height. All right. So there's those three variables set up. So now let's use them in drawing multiple keyboard keys instead of just manually doing them over and over again. Okay, so to do that, we'll use a for loop. Now, if you don't know what a for loop is, I have some other videos that cover this, but I won't go over it here. And I will equal to 0. I is going to be less than the number of keys. And then I plus plus. Okay, and then we'll draw our rectangle in here. And rect is x, y, width and height. So the x is the only thing, as we observed before, that changes. So we'll leave that blank for now. Our y is going to be key y. I'm sorry, our y is going to be 0. I don't think we put a key y. And our width will be key w that we calculated. And our height will be key height that we calculated, well, or we just said it was going to be the height of the canvas. Now, if you recall, when we drew those three keys, we start at 0. The second key was at the key width, right, or 40, I think it was. And the next key was at 80. And so basically, we're just doing multiples of the width of the key. So it's going to be something key width, right? And then it turns out that it's times I, because I is iterating through number 0 up to 1 less than the number of keys. So in this case, I guess 48, so 0 through 47, which will give us 48 keys, really. And if you walk through it, 0 times the key width is 0, so the first key starts at x0. And then if we imagine the next key needs to be 1 key width over, so when I is equal to 1, key width is equal to key width, and the third key will be 2 key widths over, etc. 2i, 3i, etc., etc. Okay, so if we run that, we should all of a sudden, magically, have a keyboard full of keys, which is great. And if we had our mouse theremin hooked up, which I don't right now, which I probably will do soon, we'd be able to play the right pitch by hitting the keys. Well, let me go do that. I'll be right back. Some code from previous tutorials that allow me, and I ran my Super Collider code, which will allow me now to play my mouse as a kind of mouse keyboard, mouse theremin. Okay, right. So, and you can see the other tutorials and catch up with the OSC messages, but basically this bits here are sending some messages to Super Collider so that we can actually make this sort of OSC enabled keyboard. All right, but do catch up on the previous videos. I'm going to stick to the GUI on this one. So that was quite easy. Now a couple enhancements we can make. One being that we can now create black keys and white keys, so it really looks like an actual keyboard. So how do we do that? Well, we'll just use some conditions here. And in this case, I'm going to use if statements here. All right. So if you think about it, we'll change the fill of the key. It'll either be black or white depending on what its location is. All right. So if you think about, since we're starting at C, we'll just think about it that way initially. If you start at C, the next key should be a black key, correct? So it should be C#, right? So what we'll do is we'll use an if statement, and we'll pretend that we'll always start from C for now, and we'll make that adjustment later. But if we imagine I to be equal to 1, because that's a second key, right? The 0 is the first key. Then our stroke will be, our fill will be black, right? And we'll have an else, and we'll just make the fill white if it's not satisfied that condition. Okay, so that should do it for our C#. Right, very good. Okay, now how about all the other keys? Well, we can continue on in this vein, and we can use this operand, which is ampersand ampersand, which means and. So ampersand ampersand means it has to fulfill, it means and, so it has to fulfill both conditions, right? So if we say I has to be equal to 1 and I has to be equal to 3. That'll never happen, right? So that's and. There's another one called or, which is like that, two of those lines. And it just means that you can fulfill any of these conditions, either of them. Okay? So if we think about, if we just continue along this vein in the 1 octave, all right, we'll say, well, if I is equal to 1, that's C sharp. 2 is D, it's a white key. 3 is D sharp. So we'll do 3. Okay, and now it should make a C sharp and a D sharp, which is nice. Does that. Okay. Well, so we can continue on that vein. We can say or, and our next accidental happens at 3, 4, 5, 6. I is equal to 6, and then we'll just finish out the keyboard. That's F sharp, I is equal to 8, that's G sharp, and I is equal to 10, which is A sharp, B flat, right? So hopefully we have an octave full that looks just like the 2 and the 3, the familiar 2 and the 3, 2 white keys, 3 black keys, etc. Okay, and does essentially correspond to our chromatic scale. Now, how do we make this, if we change it to a multiple octave, do we have to go through each one and do that? Well, no, because what we know it repeats at the octave. So what we can do is we can use a modulo. Okay, so if we can say I modulo 12, right? Because there's 12 keys to the octave. So every time I gets to 12, it resets back to 0. Right? So let's see how that works. So now we should have 2 C sharps, and it's right where it should be. Right? So if we go ahead and fill that modulo in for each one, each of the I's, it will repeat itself every 12 keys. So it doesn't matter how many octaves. Oops. It messed up something here. Oh, I modulo 12. Sorry. Right. Of course, 12. So no matter how many octaves we have, it'll fill out the keyboard. And you notice with just these few lines of code there, very simple, we can create a very flexible, versatile keyboard, right? So we can change the pitch low to high. You know, if we make that something ridiculous like 1 and 100, we'll create a lot of really small keys, and the 2-3 pattern will repeat itself all the way through. Okay, so that's how you create a very versatile keyboard. Of course, you have to remember to change your mapping, and you can make that variable as well. So, oh, which we did. We did pitch low and pitch high. So now it will map between those octaves. So if you run that, I don't think we can hear these down here. Yeah, they're too low. Oh yeah, well that's really boo. Okay, there you go. See, they still function nicely, and it maps the pitch correctly. Great. Okay, so that's a really nice, easy method to create this very versatile keyboard. Now there are just a few other things that I want to fix. Let's put this back to a sane range here, 48, and we're going to go to 72. Now, in fact, if you have perfect pitch, happen to have perfect pitch or really good relative pitch, you'll notice that this really is our 48, is our C. It's really at the edge, right? Because it's mapping from 0 to the width. So that's our edge. What we really want kind of is to be the middle of the key, really to be the C, or dead on C, right? So we basically just have to scooch everything over, don't we? So is nudge everything over half a tone, right? If each key is one half step or one tone, we want to nudge it over 1/2. But we want to do it after we do all this calculating. So we're going to calculate the number of keys based on the pitch low and pitch high, but then we want our mapping to be done to something that's half a step lower. Okay, and see if you can see what I mean. So if we do pitch low, low, and then again after this process happens, after we calculate the number of keys, will equal itself, will equal pitch low, but just subtract 0.05, 0.5, right? Okay, so we're actually then in fact mapping the 0, which will be the left edge of our canvas will be half of half step, or 1/4 tone um, flat, lower than the middle C, right? Well, let's do the whole thing before I draw it. Okay, and then pitch high, we have to shove that down too as well. Will equal to pitch high minus 0.5. Okay, so if you run that, if you think about that, before that was the C right there, right at the edge, right, 0. But now since we're mapping from not 48, but this is 48 minus 0.5 of pitch, so 47.5, then this becomes 48. Okay, but we want to keep the range the same, otherwise it'll mess up our mapping. So basically this at one point was 72, right? But right now this is 72. Right, it's 72 minus 0.5, so 71.5. So that's 71, right? Because 72 is really the next key over. So that's 71, which is B, right? 72 is the next C, right? Which makes sense. Oops. Okay, so we just shoved everything over. So now, again, if you have perfect pitch, you should hear that that should be closer to the 48C, and that should be closer to middle C. Not before it used to be this. That used to be middle C. Okay, so now we have the middle of our keys playing the pitches we want. Okay, so essentially that's done. That's great. Good luck with that. I hope you enjoyed that keyboard. Again, you could, make it whatever you want. You can change this pitch and do whatever you want. Oh, sorry, there's two more things I want to show you. One thing, and then kind of a bonus little thing that you can stop and watch. You can watch, or you can stop and not watch. So this part is really, what if you don't start at C? Then that's going to throw off your black-white key sort of thing. All right. So we have a nice little trick. We're going to create a starting partial, so we'll know which partial we're on. We're going to make it an integer up here. Create another variable. We're going to call it start part. Okay, and then to calculate the start partial, we're going to do it after, of course, we calculate the keys and all that. And we're going to make it equal to the pitch low, and it's going to be modulo 12. Okay, and why that works is simply because 0 is C. 0 in the MIDI system is C, right? Okay, so if for example, our start partial is see 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That would be 12. 0 is 0, and when you get to the B right before C, that's 11, and when you get to 12 again, then that under modulo 12, pitch low modulo 12, when pitch low is 12, which is in the next C, right, it's 0 again, right? So you always have the start partial being one member of the octave. So the modulo 12, just like we did earlier with figuring out where the black keys go, will give you the octave displacement of it. It'll tell you relative octave where you are, relatively within the octave, I'm sorry. So, so you can have a start partial, and you can know what start partial you're on. Okay? And then to implement your start partial, you just go, you just now start at the start partial instead of I, and you iterate from there. Okay? So, let's see what we do. Yeah, right before the if statement. So within the for statement, you're going to create just a local integer. We're going to call it n, and we're going to say it equals I plus the start partial. Okay, right. So because that will it will offset everything. Okay, and then of course now these need to all change to n's, and then it'll offset everything, and it should still work. And then I think this is N2 as well, of course. All right, so let's try starting at D, so 49 instead. Oops, what did I do? Oh, right, sorry. So this was a float because it's helpful to have a float there, but we'll just convert it to integer. So we'll say int pitch low modulo 12. I believe that's how I did it. Just want to make sure. Right, okay. All right. All right, so we're actually not drawing n, because that'll mess things up. We're drawing I. We are drawing still I. So we're doing I number of keys. We're going to draw that number of keys. This is just a shading, right? So n just needs to be offset where we start the shading, or where we turn them black and white. Okay, so that'll work now. We just keep I there. That's the mistake I made, right? So actually, sorry, D sharp. Of course, we're starting on D sharp. So if we want to go 50, that will be D, and just offsets the way we pattern the black and white keys. Okay, so there you go. The start partial there will give you a nice offset, so you can start at a different pitch than C, your keyboard. And again, we're taking the modulo 12 of the low pitch, because it happens that in the MIDI system, key 0 is C, so it nicely fits within an octave. And then we're changing the I to N here just for this if statement, so that each of these modulo 12 will change the pattern of black and white keys. Okay, so there you go. You have a nice, useful keyboard. You can scale it up, and do look at the previous videos, or you can just look at this code here and to see how I send these OSC messages based on where my mouse is located. And it could be, right now I have a mouse theremin set up in SuperGlider, but it could really to be any app that takes OSC messages. You'll send a proper pitch and a proper amp there. Okay, and you just send them through to wherever you want to send them to. And so you have a real useful sort of MIDI keyboard GUI, and you can change the size and shape and color and however you want. Now I'm just going to show you one bonus thing, so end the video if you're happy enough to do it, or continue on. But what I want to show you is, like a perfect pitch kind of thing. So what we'll do is it'll be a few steps. What we'll do is we'll kind of detect where we are, and we will send not a mapped pitch, but we'll send a rounded pitch, so that no matter where we hit the key, it'll always be, say, C or C sharp. It'll just be dulled to the half step. It was a few steps earlier. I think I meant to say it's easier than I thought. So, so basically, you just round it down. So if you say pitch equals floor pitch, then it will round down. But if we think about it, in fact, not quite right, because we did that little adjustment. So right now we're at, I forget, let's say that's middle C, right? 60. Right now we're at 60. But as we scoot down here, we're at 59. We're a little bit less than 60. So that'll drag me down to the B. Okay, if I floor it, that means I round down every time. So as soon as I get down below 60 to 59.9, 59.8, it'll round down to 59. Okay, so we just have to scooch it back up. I know we scooched it down, scooch it back up. We can just either comment this stuff out, or instead of doing that, we'll just keep the integrity of that and say if we want to round it down, we want to make it a perfect pitch, we'll just have to scooch it down, back down to, and then floor it. Okay, so we'll say pitch, let's see, I guess it'll be plus 0.5, right? So plus 0.5. And then round that down, right? So let's test that theory. So if right now, if on the earlier system we were at exactly 60 here, with the plus 0.5 we'll be at 61. Oops, is that right? Right, no, it's the other way around, right? So if we are here at 60, we want to be at, no, right, so we're at 60.5, that's right, okay? And then, but which will get round down to 60. Here we'll be at whatever, 60.4, 60.3, 60.2, 60.1. It's all still rounded down to 60. Up here we'll be at 60.5, 60.679, right? So that does it. That'll give us. So same thing with the amp. We don't need to round, so it's just a pitch. So it's actually quite simple. So we'll put a little comment here. Makes each KY. This is the worst wording. So, but you know what I mean. So it's just dull to the half step. So if you want microtones or you want the slide or something like that, you'll just comment that out, right? But if you keep that, then no matter where I hit on the G, it'll always be G, F sharp. So I can't play out of tune. No matter where I play on the key, it's giving me that note. Okay, well, there it is. Wrap that up. So there's your keyboard tutorial. Again, if you want to play glides or something like that, we'll just map that out, and then you can go. So you don't get those jumps and stuff like that. Okay, well, enjoy that. I hope that works for you, and good luck with it.